Hello guys and welcome to your channel MBA Wallah in English medium. And now today we'll hit the jackpot. Means we are gonna try some CAT PYQs that were very straightforward on the basics of linear equation. I hope you have done the equations first lecture, that is the prerequisite for this equations too. Even in case you have not done that and you know the basics of equation solving, that means you can solve two equations, two variables, you can attempt this lecture. For every CAT question, I would advise you that pause the video and try it on your own so that you can test your knowledge in the middle. So why do wait for? Let's go ahead and begin today's lecture. My name is Rahul Bathla. I'm a CAT 99.95 and a Quant 99.98 percentiler. So I'm going to go ahead and give you all my tricks and the approaches which I have learned in the past decade. This is a question CAT 2025 slot 2, another observation question which we'll be doing at the end. So in every video we'll try to cover at least one question that builds up a new approach which is not conventional, mathematical, which is actually an aptitude approach, a CAT-like approach, the modern CAT where it is going, right? So what we are going to cover, system of linear equation, very conceptual topic. We have seen around 2 to 3 PYQs in the past 5 years on this particular topic, so a gold mine. We'll talk about one equation, two variable. Again, we have seen around 2 questions on this topic as well in the past 3-4 years, gold mine. Splitting the middle term, a very basic concept gonna be used in every paper of CAT Quant. So forming the foundations as well as looking at those topics which you're definitely gonna see in the paper. Let's start with system of linear equation. So guys, you know, a pair of system of linear equation can give you a unique solution, maybe infinite solution, maybe no solutions. So rather than giving you the direct formula, let me give you just a pair of equations and we'll try to solve it. And we'll try to observe from that how actually a pair of linear equation can give us a unique solution, infinite solution, or maybe no solution. So guys, if I give you an equation like this, 2x plus y is equals to 5, and let us say 3x minus y is equals to 5, right? So what we have two equations, two variables. I want you to solve it. You can absolutely, right? Easy elimination method we have learned in the last lecture. If I add these two equations, y gets cancelled and I get a 5x is equals to 10, x equals to 2, right? And similarly, once you put x over here, let's just put x over here. So this is 2 into 2, 4. 4 goes over there. So y goes to 5 minus 4 and that's a 1. You can take your time, solve the system of linear equation, and what do we observe? We have a unique solution. We have a value of x as 2 and y as 1. It is fixed or specific value. What happens if I change the equation to this? Let us say x plus 2y equals to 4 and 2x plus 4y equal to 8. Some of us might say, are you joking with us? These are the same equations. You've just multiplied 2 over here. The idea is yes, but still they are a pair of linear equations. This is a standalone, a linear equation. This standalone is a linear equation, right? These are called as coincident equations. Coincident equations are coincident line, right? We'll learn about the geometrical nature later. But the idea is, if I try to solve this particular equation, I multiply 2 over here, it becomes 2x plus 4y equals to 8, right? And when I try to eliminate, everything gets eliminated. I get a 0 equals to 0, right? So does that mean the equation is unsolvable? No, the idea is the equation has infinite solutions, right? You can put in any x and for that you will get any y. Ultimately both the equations are same. So if I put x as 4, so 4 plus 0 is 4. So this has to be 0. That means y is 0. That is one solution. Similarly, if I put y as 2, so 2 into 2, that's a 4. This has to be a 0. 4 plus 0 is 4. That means x is 0. And so on. I'll keep going on. Right? So you will have infinite solutions. And all the solutions will definitely satisfy this equation as well. You want to put check. put 4 comma 0, 2 4 is 8, plus 0 8, put 0 comma 2 0, plus 4 2 is 8, you get 8. Take your time, put these values, this pair in both the equations, you will get all right. So this pair has infinite solution. And then let's talk about this particular equation. X plus 2y equals to 8 and 2x plus 4y is equals to, let us say, 6. Right? Pause the video, solve this one as well, and observe what happens once you solve them, and you will be intrigued. What happens? Let us try elimination again. Multiplied by 2, what do you get? 2x plus 4y is equals to 16. And there you go, when you try to eliminate a variable, goes away, we get a 0 here. 6 minus 16 gives you a minus 10, which eventually is a false equation. That means this is not possible. But we did everything mathematically right. We tried to eliminate. There was no problem in multiplying to both the sides. And eventually we lead to 0 equals to minus 10. And that means we have no solution here, right? So this is a case of no solution. You will never get a x and y satisfying these two equations. You will never be able to find it. If a x comma y satisfies this, it won't satisfy this. If it satisfies this, it won't satisfy the first one. All right. So do you see? In all the three cases, we had a pair of linear equation. One gave us a specific value of x and y. One we could not solve, right, entirely. And the one we had multiple solutions. In fact, infinite. Right? So pair of system of linear equation can be of three types. Pause the video, observe. Now the point is, how would I determine that my equation is solvable or has infinite solutions or is not solvable? Is there a shortcut? Is there a technique that I can tell you without solving it and just by seeing the equation? Absolutely there is. So what's the technique? Let's observe. See, the idea is, here when we multiplied 2, x became 2x, 2y became 4y. Absolutely same as the other equation. Right? So that means if the ratio of the coefficient of x here is 2 by 3, right? Coefficient of x, that means this number and this number. And coefficients of y, here is plus 1, here it is minus 1. And here we have the coefficient as 1 upon minus 1. So if they are not equal, then you definitely get a real solution, a specific solution, a fixed value. Because if you multiplied any number here, it will never happen that both the coefficients become same. It cannot happen because the ratios were not same. They had a ratio of 1:2. So if you multiply 2 here, then become same. If they have a ratio of 3:4, you multiply, 4 by 3 here, then it becomes same. So if they have a different ratio, you can never make both of them simultaneously same. That is why if the coefficient of x is not equals to coefficient of y, you will get a specific solution, that is for sure. And have a look at this one. Coefficient of x is 1. So 1 by 2, coefficient of x. Coefficient of y is 2 and here 4. So 2 by 4. Do you see? So the problem starts to occur when the coefficients of x and coefficients of y have the same ratio. Because see, their ratio is half, their ratio is half. That means if I multiply 2 to this, the ratio is in 1:2. So if 2 is given to 1, it becomes 2. 2 given to 2 becomes 4. So do you see? The problem is, if the ratio of the coefficients become same, they get eliminated simultaneously. Here also if you see, 1 by 2 is equals to 2 by 4. Getting the point? So the idea is, when the ratio of coefficients become equal, the problem starts to occur. Then you're not going to get fixed solutions. If they are not equal, definitely a fixed. Now the point is, how to differentiate between these two? Both the cases had same ratio. Now there is a further idea. If the constants also have the same ratio, do you see 4 by 8? That means the equation was entirely same. Everything had the same ratio. So if you multiplied that ratio, all of them become equal. And you subtract, you get a 0 equal to 0. That's the logic behind it. So nothing to be crammed now, right? So the equation becomes entirely same when all the respective coefficients and constants give you a same ratio, that means nothing. You have just multiplied the equation with that ratio. And in this case, I want the 0 here, but not here. That means the ratio of constants was not equal. Now, this is a moment to pause the video and observe, right? Next, I'll give you the formula, but the formula is something which we tend to forget. So, rather than the formula, we need to understand, see the idea behind it. The idea is if the coefficients are having different ratios, not a possibility that you multiply and both the variables vanish simultaneously. It cannot happen because the ratio was not same. How can you vanish both of them? Here, the ratios of coefficients are same. Both the variables vanishes at the same time. So, look at the constants. If the constants also have the same ratio, they also vanish. You get a 0 equals to 0, always true, infinite solution. If the constants don't vanish, different ratio, then 0 is not equals to the other number. Not possible. Now you have made this particular thing crammed like this. We will come and tell you that, okay, if the two equations are a1x plus b1y, a2yx, b2y, then if a1 by a2 is not equals to b1 by b2, you get a unique solution. And a person gets confused seeing a lot of alphabets and no numbers, and he feels like, is this math going on? Actually, it's nothing. See, you already know coefficient of x. So this is the ratio of coefficient of x. Coefficient of y. So this is the ratio of coefficient of y. And if the ratio of coefficients of variable is not equal, you get a unique solution. Simple, written in that format. So even if you don't cram this thing, I don't care. You just need to know this. The ratio of coefficients of x is not equals to ratio of coefficients of y. There you are, unique solution. They'll never get cancelled out simultaneously. Similarly here, if ratio of coefficients of x is equals to ratio of coefficients of y is equals to ratio of coefficients, or rather a ratio of constants, everything equal, you have the same equation, and if you have the same equation, you have infinite solution. That's the theory. Now we'll go ahead and test some questions, right? And then of course you can make out that on your own. That means you know the in-depth of the formula now, right? So what's happening over here? Ratio of coefficients of x, ratio of coefficients of y, they are equal. Can never have a unique solution now. But the constants, that is not equal. So this will become unsolvable. That means this will have no solution. So that is the meaning of this slide, which becomes very, untidy, or maybe something that draws us away from mathematics. We feel like, okay, I'm not going to read the maths after this. Let's stop here. But now if you know it, if you understand the logic behind it, it's very, very straightforward things. Now there is another perspective which we can look into, and that is the linear equations also represent line in the geometrical plane or a coordinate geometry, right? Every equation has a relation with a particular graph or a locus or a pathway, whatever you say it. We'll talk about all these terms later on when we go to coordinate geometry, right? For example, quadratic equation represents a parabola. Circle also has an equation. Similarly, linear equation represent a line, right? So here I'm looking for a unique solution, right? Coefficients of x not equals to coefficients of y. How can two lines, see this is a line, this is a line. How can two lines have a single solution? Now a solution occurs when two geometrical figures intersect. Okay. So if these are two geometric figures, one represents this equation, one represents this equation, then these two are the solutions. So these two graphs or these two things, a parabola and a line, have two equations or two solutions. Now these both are lines, I know, right? So how can two lines give me one solution or one intersection point? So here what do you have? One solution, unique solution. And in geometry, this refers to one intersection. Intersection refers to solution. So now I'm asking you, I need one solution or rather one intersection. I know both are lines. That means they are going to be something like this. And this little point of intersection is nothing but my solution, a unique solution rather. So this equation also mean intersecting lines, right? Sometimes the question can say that this pair of system of linear equation represents intersection line. What can you tell about them? You can tell the coefficient of x is not equals to coefficient of y. The question say that system of pair of linear equation represents a unique solution. What can you say? The question says the system of linear equation has one intersection. What can you say? The question says the system of linear equation has intersecting lines. What can you say? You can say all questions have one answer, and that is ratio of the coefficient of x is not equals to ratio of coefficients of y. Now similarly, tell me, how can two equations, that means two lines, can have infinite solution? Because you know this is a condition for infinite solution. The idea is very simple again. So this means the lines are overlapping, right? Well, one is this, the other overlaps at this, and now do you see infinite solution? That means infinite intersections. So these lines are called as coincident lines or overlapping lines. So condition of coincident, condition for overlapping, condition for infinite solution, this one. The equations are same, the lines are same, the solutions are infinite. And this is the condition for no solution. How can two lines have no solution? And by no solution, now you know, means no intersection. Think, how can two lines have no intersection if they are parallel? So this is also a condition of parallel line. Next page we have question. So it's a time that you pause the video, observe everything here. How the question will be framed? You would be given this or this. A system of linear equation has one intersection, one solution, or represent intersecting lines. And you can refer that this to this so that you form equations. Similarly, you will be given either this or this, and from this you have to refer back to the condition this. Question can tell you that the equation has no solution, no intersection, or maybe the equations represent parallel lines. You have to refer back to this. Pause, everything lies over here now. It's time we go ahead and try some questions, isn't it? Let's go. Now it's your turn, guys. Okay, I'll take a side. Time for you to solve the question. Try on your own. It says find the value of P and Q if the pair of the equations has infinite solutions, right? Infinite. So this will tell us in which direction we have to head. Infinite solutions, that means the equations are same. And if the equations are same, that means the ratio of x coefficients, y coefficients, constant terms, everything has to be same. Coefficients of x, 2 by q. Coefficients of y, be careful of the sign, right? Not p by minus 6, p by 6. Just pardon me here, this has to be a y, right? Not z, does not make any sense, right? Let me just correct it over here. Okay, so y. So 2 by q and p by minus 6 is equals to 8 by 24. Perfect. Nice. Now try it out. What do we have? We have 1 and 3. So I can compare these two first because this is also equals to this. So 2 by q is equals to 1 by 3, and then I can compare these two. That means p by minus 6 equals to 1 by 3. Solve the equations. So q, 3 into 2 is 6, q becomes 6. Here 3 into minus 2, so p becomes minus 2. And you're asking me P plus Q, that's minus 2 plus 6. So P plus Q is a 4. Got it? Simple, easy. So if you know the concept, these questions are easy. Let's try one more. And this time, let's make it a CAT 2020 slot 3 question. CAT PYQ. So go ahead and try it out. All right, now on your own, please. Okay, assuming you have tried it on your own, now it's my turn. It says let K be a constant, the equation Kx plus y is equals to 3 and 4x plus ky equals to 4 have a unique solution. Perfect. What do you mean by unique solution? A single solution, a single intersection. That means the coefficients have different ratio. So K by 4 coefficients of x should not be equals to coefficients of y, that is 1 by k, that's it. K square is not equals to 4. Make sure you don't answer 2. It's plus minus 2, right? 2 square is also 4, minus 2 square is also 4. So k equals to plus minus 2, and that's not the answer. Be careful again. Remember, the idea is k is not equals to plus minus 2. Sometimes in hurry, we make such mistakes and get it wrong, right? Make sure that's why you write down the sign correctly, right? So if you're also getting a made a mess of a simple question, right? Yes, CAT sometimes get generous, give you an easy question, but the idea is you have to hunt it in those 22. Not every question looks like this. We have seen it in the last lecture. Let's have a look at another one. This is a little recent one, 2024 slot 3. Again, based on the same thing, as I told you that this particular concept has been tested multiple times in the recent year, 2024, right? Just last to last CAT, I guess. All right, pause and try. Okay, assuming that you have given it a fair try, right, and not just binge watching the video like your Netflix or Prime, it says a necessary condition for the system to have no solution. So you caught us. We were just binge watching. No, that's not the way to study, guys. No solution. So there is a mess. No solution. That means, of course, the coefficients have to be same for the ratios at least, right? Because if they are not equal, you will get a unique solution, and you are not getting that. But the equations are not same as well. Otherwise, they would have been overlapping. Infinite solution. It says no solution. That means this is not equal to C1. That means what do we have? We have P by 3 is equal to minus 4 by K is not equal to 2 by A. Now the idea is I have to solve each of the 3 pairs, 1 and 2, 1 and 3, and then 2 and 3, and then match which one is necessary, or I apply a little brain, right? Or I apply a little aptitude. See, what I know is that the equation which will be formed using this two will involve P because I have a P, will involve K because I have a K, and will involve a equality sign, right? So if you compare these two, you will have a P, you will have a K, you will have a equal to. Do we have any option with P, K and equal to? This is not having a P, this is not having a K, this is not having a K, this is having a K and P, but it has unequal sign. And we know with P and K come equal to sign, so this is not an answer. Next, we know if I compare these two, I'll have a K because it is here, I'll have a because it is here, and it will have a non-equal sign because when these two are compared, there is a non-equal sign. So let's search the AK one. We have this one, and AK comes with a non-equal sign. This stands a chance, right? This is a possibility. We'll keep it for now. Once we compare these two, so this equation will become P by 3 is equal to or not equal to. So P by 3 is not equal to 2 by A, right? Because this is equal to this. So P by 3 is not equal to 2 by A. So the one which is having a P, which is having a will also have a not equal to sign. So P, A and not equal. Oh my God. P, A and equal you are giving us. Wrong, wrong. This only stands a chance. I have not solved. Otherwise, I would have solved also, if there would have been multiple options with A and K and non-equal to sign, then I would have solved. So this is one way, right? I just applied the aptitude. I knew that P and K will give me a equal to sign. P and K, you're giving me an equal, wrong. I know K and A will give me a non-equal sign. Fine, that's a possibility. P and A will give me a non-equal sign. You have given us equal to, gone. Otherwise, if you want to solve it, the idea is P by 3. Now I'm only solving the right one, right? So the right one is this one, right? K and A. So let's just solve the right one. Forget about this one. So minus 4 by K not equal to 2 by A. 2 into minus 2, right? And that means we have minus 2A equal to K, or K plus 2A equal to 0. I think that is what they are giving us. K plus 2A equal to 0, right? Not equal, rather. Fine. Got it. That's how you can handle this one, either by the aptitude, or then I've just shown you solving the correct one. Okay, you can solve each pair and get the answer. Okay, let's go ahead and try another concept, right? Let's add more things to our conceptual bag. So here's an equation. It says 7x plus 4y 91. We have just one equation. We have two variables. We can never find it out. But as soon as you tell us that x and y are positive integers, right, we can start thinking about it. Okay. If not the fixed values of x and y, at least we'll give you some possibilities which x and y can take, and limited possibilities, not like many or infinite, right? Now, how to solve these kind of equations? We have one equation, two variable. The only extra thing we know is x and y are positive integers, right? So guys, the first step is to apply hit and trial method and try to find out one solution. That becomes our reference point. Okay, listen to me very carefully again. We try to find out one solution, one value of x and y that satisfy this, and that we do it by pure aptitude observation, or maybe just hit and trial. Once we have that one point or one solution, then there is a trick by which we can use that as reference and keep moving ahead to find out the next solution. So the first step, try to identify first solution manually, hit and trial. And you can easily do that. See, the best is 91 is a multiple of 7. I see that. So I know if I make 7 into 13, so if I take x as 13, 7 13 is 91, right? So if I put x as 13, I already have a 91 on left hand side. I wanted to have a 91 on right hand side, so this becomes 0, and that means y has to be 0. So this is first hit and trial solution, which I can easily find, right? So 7 13 is 91, I'll get all the 91 from this guy and make it 0. Simple. Now I have the first solution, right? I made this guy 91 equivalent, so this has to be 0. Y 0, 7 13 is 91. So my hit and trial is done. Now is the time. HNT means hit and trial, right? Now, how to find out the next one? Now you might be thinking, sir, how is this 0 allowed? X and y are positive integers. No, this is my reference point. I can get the further solutions using this, and then I'll not count this in my final solution. I'll get rid of it. That's my choice now. At the end of the video or at the end of the question, whether to count this or not. I'm getting this as an easy reference point. I'll use it. Later on, I'll get rid of this. I'll not count it simply. Now, the next solution, see how to find it out. I know this is the number which I need to increase. If I decrease it, this becomes negative. And I know if I want to increase this number, that means I'm increasing this value for y, isn't it? If I put y as 1, this becomes 4. So I'm increasing this. And sum of these two is a constant 91. So if this gets increased, think what happens to this. Will I have to increase this or decrease this? See, I cannot increase both of them. The number will go past 91, 91, sorry. So that means I have to decrease this one, right? So one gets increased, one gets decreased. We can balance it out. Let us say we both club and have a weight of 90 kgs. Now, if I get rid of 10 kgs, you have to gain 10 kgs so that we are even, right? In terms of the sum, right? Sum of the weight is 90. I am 60, you are 30, let us say. I became 50, you became 40, again we are 90. I became 40, you became 50, we are again balanced, right? So if this is going up, this has to go down. So if I add something to this, I have to subtract something to this. So the idea is simple, hit and trial. Add something here, subtract something here. Now point is what to add, what to subtract. In the y, add the coefficient of x, so plus 7. In the x, subtract the coefficient of y, right? So coefficient interchange, 4 come here, 7 come here. This to be added to make this positive, this to be subtracted. Watch, pause and learn. You're learning a crucial step, right? A new thing, it will take time, it's okay. Idea is first is hit and trial. I made this 91, this 0, 7, 13, 13 and 0. And now I knew that I have to add something here, so that means I have to subtract something here because I needed this as a positive guy. Now what to add? The coefficient of x, crisscross. What to subtract? The coefficient of y. So 13 minus 4 is a 9, 0 plus 7 is a 7. Test it on your own, you will get the answer. I'll do it for you. 7 into 9, 63 plus 4 into 7, 28. You get a 91. The equation holds true. Isn't that beautiful? Now we can keep doing this and get the answers. Minus 4, I get a 5. Plus 7, I get a 14. Minus 4 again, I get a 1. Plus 7, I get a 21. All of them satisfy. Now I cannot go further because if I go further, I'll get a negative number. That's not allowed. Stop here. And even remember, don't count this. These are our answers. Why would I count this? This as a 0. So final answers for me, if x and y are positive integers, is 9, 7, 5, 14, 1 and 21. That's it. So I have 3 solutions for x and y. Perfect. Now maybe sometimes the question gives us an extra hint. Let us say the question says us that x is greater than y. Then I can tell you that it has to be a 9 and 7. Here x is less than y. The question says both are single digit. 9 and 7, again I know. The question says none of them is greater than 20 and their sum is greater than 16. 9, 7, 16, not possible. Sum is greater than 16. None is greater than 20. This is also eliminated. This is the answer, 5 and 14. So you can have extra informations to get to a unique x and y also. Right. But the point is that all the things we will be able to do very easily. The idea is, can we solve this quickly? Yes. Hit and trial. Add the coefficient of the other variable to the one which you need to increase. Now until you subtract from the other one. And what to subtract? The coefficient of the other one. I hope you have learned it. This is a beautiful technique or a beautiful skill to gain if you're looking for acing quantitative aptitude. Specifically equations, let's try one on our own. Now remember, this trick does not work always. So what is the point of learning that? So it works always. The idea is thus, you have to just simplify your equation. So if the equation is given to you like this, it can be cancelled, not in the very simplified form. The coefficients have to be co-primes. They cannot be the ones like I can cancel both of them. 2 1 ja, 2 5 ja, right? So that means 2 and 10 were not co-prime. This is the meaning of co-prime. If two numbers can be cancelled by an integer, positive integer, right? Then they are not co-primes. If they cannot be cancelled, they are co-primes. So see, in the previous question, they were co-primes. You cannot have a number that can cancel 4 and 7. They were co-prime. Here there is a number 2 which can cancel both of them. They are not co-prime. So we'll cancel out. 2 1 ja, 2 5 ja. This also becomes then 250 ja. We have taken away 2 from the entire equation. Now we have 5x, we have plus y, and we have a 50. I am giving you x and y are positive integers, right? Let's just change the question. This time I give you non-negative integers. Non-negative integers, that means 0 can also be counted now. Solve it now. Take your time. Solve it, solve it, solve it. My turn. Okay, assuming you paused and tried. X is 10, 5 10 of 50. We have already created 50 balanced. Y is 0. Y, X, hit and trial done. I told you it's easy. Right? If we can find out that 50 is a factor of, sorry, a multiple of 5, it's easy. Right? Next, we'll subtract the coefficient of Y from here. We will add the coefficient of X from here. Done? So 9 and a 5. We'll subtract again. We'll have a 8. We'll have a plus 5. That's 10. See, now you have to do little faster. You know, 1 will keep getting subtracted. 5 will keep getting added. Here there is no problem because this number will keep on increasing. It will never reach my threshold point. I just want my numbers to be non-negative integers. I don't care whatever positive you have over here. This is the problem. This is decreasing. And one day this will become a 0. One day this will become a negative. And that will be the point I don't have to count any furthermore. So which one has a critical case? This one has a critical point. I will have to stop on the basis of X. I'll never stop on the basis of this guy. Right, this will keep on increasing 10, 15, 20. Never gonna be a problem for me later on, but this will become 7, 6, dot, 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 one day 0, and then a minus 1. So this is the point I need to stop. This will keep getting increased. No problem. I'm not gonna count each and every one. Now I can, just simply count it out. The 10 options here, 1 to 10, and 1 is this one. So 0 to 10, 11. Remember 0 was also there. So we have 11 solutions. Simple. So sometimes the question just simply asks us how many solutions. Now you cannot keep writing 11 solutions. Think smartly now. Yes or no? On a certain day this will become 0, and after that you will never count. It will become negative. 0 to be counted. I am saying non-negative integer. 0 allowed, negatives not allowed. Got it? Perfect. And in case you're not able to figure it out or visualize, I would advise write all today, so that you actually get it very, very clear why I'm just focused on X. Because this guy is never a problem for me. This will keep adding. There is no chance this becomes a negative. This will definitely become one day. Yeah. All right. Imagine you have in the future, let us say, 2 sons. One is very capable, very disciplined. You don't have to worry about that guy. One has a poor company, undisciplined, not capable. You have to worry about that guy. That he does not become a 0 on a day. So that is this guy. He is increasing every day. I don't care about this guy. Yeah. All right. Let's jump to the next concept for the today's lecture. Then we'll try 2 more CAT PYQs, very recent, 2023 and 2025, I believe. Okay. So let's understand. We have splitting the middle term, right? How to solve quadratic equation. We'll be solving it in each and every question, right? In the coming time. X square minus 8x plus 12 equal to 0, right? See, the first way which we have been doing in the schools is we'll try to hunt for 2 numbers which product to 12 and sum to minus 8, right? So x square, 6 and 2 comes. So we say minus 6x minus 2x plus 12 equals to 0. Remember, we used to think 2 numbers whose product is 12, sum as this, and then we think, okay, minus 6 minus 2 we can write because the product is 12. And then we used to take x common, x minus 6, minus 2 common, x minus 6. And then we used to write x minus 2, x minus 6. We have done this a lot of time from class 8 to class 10. And eventually we get x as 2 and x as 6. Now this is something which we used to do in early days, not now. Now we have a simple technique. We'll think of 2 numbers whose sum is equal to the coefficient of x, but we need to just change the sign of that coefficient. So if it is a minus, we'll change the sign while going from here to here. And once you change the sign, minus 8 becomes 8. Product, same as 12. This is the product. Now you're done. What are the two numbers? Whose sum is 8, changing the sign of coefficient of x. Product a constant, simple, 6 and 2, right? So 6 plus 2 give us 8, 6 into 2 give us 12. That's our answer. X is 6, x is 2, and we are done. See, you can match it. So the next time I get a quadratic equation, I'm going to solve it like this. If it is possible, sometimes the coefficients are in that form where you're not able to figure out those two numbers. Maybe they are going to end up in the roots, and then I'll have to follow the other method, the discriminant method, which we are going to learn in the quadratic equation. But this is something which will help us to solve 70 to 80% of the quadratic equations, right? And if it comes out to be in arithmetic, then definitely they are going to be solved by splitting the middle term. Let's practice this more. Here are two equations, try it on your own. But the only thing which I've changed is I have, added certain coefficients behind x square. Here there was no coefficient behind x square. Now once I add a coefficient behind x square, something change. We'll try to see that, right? But for going ahead with those, I would want you to solve this one first, so that we can actually observe what happens. So I'm giving you an equation, x square minus 11x plus 28 equals to 0. So solve this one first. Right. Solve this one, then we'll go to that. I'll solve this, you'll solve that. X square minus 11x plus 28. See, beautiful. Again, the sum should be equal to not minus 11. Remember changing the sign, 11. Product, 28. What are the two numbers? 7 and 4. They are your answer. You are already done. So x7, x4. Got it. How about this one? See, the idea is, again, I'm looking for two numbers whose sum is equals to the coefficient of x, but I need to change the sign, so 23. But the product is not 18. Actually, the product is the product of these two guys. Here also we are producting the coefficient of x square and the constant term. But the point was it was 1. So 1 into 28 always became 28. There was no problem. But here the coefficient of x square is not 1, it's 7. So you need a product which is equals to 18 into 7. That's 126. That's the only change. Rather than the change, here also you were doing the same thing. But the point was, you just did not know it. And one was not creating any challenge as well. Right? Let's try to solve it. Think of two numbers, sum to 23, product to 126. And I guess we have those two numbers, 14 and 9, right? So 14 plus 9, that's why I say you need to get your tables right. Learn from 1 to 20. You should be spot on and not just, cramming the table. It should be something like if I show you 144, your mind should say 16 into 9. That's how you learn the table, right? All right, maybe 12 into 12. So 14 and 9. So that means x is equals to 14, x equals to 9, and that's the wrong answer. Sir, what? We could figure it out, it was 40 and 9. Now you're saying it's wrong answer. See, the idea is, the final answer which we used to get here, they were 7 and 4. They were not actually 7 and 4. They were 7 upon the coefficient of x square. That means 7 by 1 or 4 by 1. Since it was 1, there was no problem. Here the coefficient of x square is not 1, it is 7. So it will have two impacts. One, it will make the product 7 into 18. The second one, you get the final answer divided by the coefficient of x square. So divide by 7, divide by 7. So the answers are 2 and 9 by 7. Still we are fast, right? So these are your answers, right? So sum, change the sign of the coefficient of x, write it down, product, first and the third. That means coefficient of x square and constant term. Once you get the answers, divide them by the coefficient of x square. Now your turn, try that. Pause and try. If you get the right answer, superb. Right. My turn. I hope you've tried it, right? Not binge watching. I'm looking for two numbers. Sum to 29. You know why 29 not minus 29. Product to 18 and 3, that's 54. What are the two numbers? 27 and 2. 27 and 2. 29, product 54. So x is 27 and x is 2. No, remember, divide by the coefficient of x square. So one is 9 and the other is 2 by 3. If you get the right answer, congratulations. You understood it well. Now you can solve any quadratic within quick time. So let's try this question. This one is a little difficult, right? I want you to try it. Okay. Try this one. CAT 2023 slot 3. A difficult one, but you can do it, alright? I'm counting on you. Just take your time. Try. Take your time. Take your time. Pause and try. Don't waste this question. Superb question. If you can make it, you are there. You have it. Easily get a 97, 98 percentile plus in CAT Quant. Yes, with a little practice, maybe 99 plus, maybe 99.5 plus if the day is also on your side. Maybe 100. Who does know? Who knows it? Nobody knows. Maybe you are the one. Let's try. Okay. For some real numbers a and b, the equation this and this has infinite solutions. So it is combining the pair of linear equations and maybe a quadratic later on. Why? Because you have a coefficient as b. Now, I have one equation as this. I generally have the habit of writing the more complex equations first. So this is one equation. Something coefficient of x, nothing else. So this is the equation in x and y, and this guy is a coefficient of x, this guy is a coefficient of y, this is a constant term. And what is the other equation? The other equation is x plus y equal to 4. This is a simpler equation. Coefficients are 1. And you're saying that they have infinite many solutions. So infinite many solutions, what does that mean? Infinite many solutions means the equations are same. The ratios, everything is going to be equal. So what do I have? A plus 5 upon 1, the coefficients of x, is equals to coefficients of y is equals to the ratio of constant. So here is our equation. A plus 5 equals to b square minus 15 equals to 2b. 4 right? Now, I have three possibilities to move ahead with. I can form three equations. This equals to this 1, this equals to this 2, and this equals to this 3. Pause the video and try. Which one should I move ahead with? This, or this? The idea is why to involve two variables when we can form an equation with one variable. So I would go with this and this. Both have only one variable intact, that's p. Let's go ahead. So what is the equation we get? We get b square minus 15 equal to 2b. Time for splitting the middle term. Quadratic b square minus 2b minus 15 equals to 0. Think of two numbers that sum to 2 and product to minus 15. Be careful. Minus is you don't change the sign of constant, right? You just change the sign of the coefficient of b here. So instead of a quadratic in x, it is a quadratic in b. Think of two numbers and we'll get the value of b. Two possible values though. So I guess 5 and minus 3 work, not minus 5 and 3. Minus 5 and 3 will make it a minus 2. So the things that work are 5 and minus 3. Sum 2 and product minus 15, right? So I get the value of b. b is either 5 or b is either -3. Perfect. So I know the value of b. We have two values. Now the point is how to find out a. It is very simple. Let's use this equation. I don't want to calculate this. It's a square. Simple. Let's find out a now. There are two possibilities. Let us say if b is equals to 5, what is a? I know a plus 5 is 2b. So if b is 5, then a plus 5 is 2 5s are 10 and a comes out to be 5. So if b is 5, a is 5. Similarly, why don't you pause and try to find out a when b is -3? So b had two possibilities, isn't it? So what if b is -3? Again, we have the same equation, a plus 5 is equals to 2b. So a plus 5, 2 into -3, -6. So a comes out to be -11. So if b is -3, a is -11. The questions asked is then the maximum possible value of AB. So we are looking for the value of AB. So if this is the case, then AB is 5 5s are 25. If this is the case, then AB is equals to -11 into -3, that is 33. So which one is maximum? 33 or 25? I guess this is the maximum, right? So AB is 33, the right answer, 25 is a trap. Even though if you get 25 today, you are good, at least a 90 guy. And if you get 33, you are already a 95 to 97 guy. So why not 99? Because I have not tested you on other modules. This is just algebra. For algebra, yes, 99 plus 5. It's a good question of algebra, right? 2023 was a difficult paper. It's good if you got it right, right? So the idea is, first tested us on the system of linear equation. Coefficients of x equals to coefficient of y equals to constant terms. From that we have an equation. We chose this too. When we use this to find out the value of b, we get a quartered x. So we get two values of b. And for both the values of b, we found out the value of a using this and this. Now we had two values of b and corresponding to values of a, we found out ab. Maximum 33. And now as promised that we'll try to see multiple approaches in each and every lecture we have, maybe recorded or live. We'll try to learn new approaches, new kind of questions. Yes, they might look challenging and difficult in the first look, but what's the point if we do not take up challenges? CAT itself is a mammoth challenge and we are looking forward to it. That means we have to face these challenges. Maybe if we are not able to do these questions, doesn't matter. We have learned a lot. Maybe we have learned a new approach. That is why I bought those. You have to make sure that you have understood the system of linear equation. You are able to solve the basic quadratic equation. You are able to do the splitting the middle. That's the catch today. These questions, they are just there to build the new approaches. Try. Pause and try. Don't waste it. It says 2025, right? Brilliant question, 2025. Suppose a and b are three distinct positive integers such that 3ac is 8a plus b. Then the smallest possible value of 3a plus 2b plus c. See, how would we approach this question? Very beautiful. It says 3ac is equals to 8 times a plus b. Now the point is, we know that a and b are 3a, b and c. Right here, c should also be mentioned, a and b and c. Perfect. Now all of these are positive integers. That means this product is going to be an integer, integer into integer into integer. So this is going to be a positive integer that is a multiple of 3, right or not? So left hand side is a multiple of 3. Similarly, this is 8 into sum of two integers. So that means 8 into an integer. So can I say that a right hand side, this side is a multiple of 8? Yes or no? So this entire side is a multiple of 8. This entire side is a multiple of 3. Yes or no? How can you make them equal? This side has a 3 but needs a 8 because the equality stands, and this side has a 8, so this also should have a 8. So like this guy has a 8 but not a 3, and this guy has a 3, so this has to have a 3. That means the 8 on the left hand side will come from here. So this AC has to be multiple of 8. And similarly, this number, this is 8 into something, I need a 3 here because I have a 3 on the left hand side. So this has to have a multiple of 3, right? If this guy does not have a 3, they can never be equal. How would you take care of this 3 on the left hand side? They are equal. Remember in the mind, they are equal. See, we both are equal, let us say. And I say I have a 3. That means you also have to have a 3. Otherwise, we can never be equal. And you say, sitting over there, I have a 8. I also have to have a 8. How can we be equal otherwise? Now that's happening over. I need to have a 8 because you have it. You need to have a 3 because I have it. Yes. Because 3 does not carry a 8. 8 does not carry a 3. They don't have any prime number common. That means this guy must have 8. This guy must have a 3. Now you're looking for the smallest possible values. So it is a multiple of it. It can be 8, 16, 24, 32. I want smallest. So why not put AC as 8? I want to put AC as 8. That's the smallest I can get. And I want to put A plus B as 3. That is how I can get the smallest possible values. You're asking for the smallest. I'm not going to make it 30. A and B have to be larger numbers. I'm not going to make it 80. These are the smallest I can do. You need to have 8. Okay, I'll give this 8. This becomes 3 into 8, 24. This becomes 8 into 3, 24 equal. And now, what are the possibilities? How can you make two positive integers product 8? 1 into 8 or 2 into 4? 4 into 2 or 8 into 1? These guys do not stand a chance. Why? A plus B is 3. Right? Only possibility you have, they are positive integers. Only possibility you have is 1 plus 2 is 3. 2 plus 1 is 3. There is no other possibility. Not even 3 plus 0. They are distinct positive. So A can either be a 1 or be a 2. Right. So we have 3 possibilities, or rather 2 possibilities now. So if A takes 1, right? So if A is 1, B is 2. And what about C then? So if A is 1, C is 8. If we go with this one, A is 2, then B is 1. And what about C? So if A2, C4. So these are the 2 possibilities. These are the 2 minimum possibilities we have. Minimum A, B and C can get. And we needed the minimum of A, B and C because here you were adding 3A plus 2B plus C. So all were getting added. These are the minimum possible values of A, B and C. Let's put in here. If I put this one, what do I get? 3 plus 2 into 2, 4 plus 8. So 8, 4, 12 and 3, 15. Right? I guess we get a 15, right? 3 plus 4, that is, right, 7, 7 and C 15, right? What if I put this one? 3 into 2, that is a 6, plus 2 into 1, that's a 2, plus 4. So 6, 4, 10, 2, 12. So I get a 12. So I guess this is the best we can do, right? So what is the minimum possible value? Minimum possible value is 12. A pure aptitude question, right? Do you see the modern cat now, guys? We have done these kind of questions in the last class. I gave you AB 127. There were only one possibility. Again, I gave you. CAT asked that in 2025, isn't it? But you have to think that way. And start thinking from there, because this will give you just 2 possibilities, very limited. This will give you multiple. This will give you 2. 1 plus 2, 3. 2 plus 1, 3. Even you cannot have a 3 plus 0, 3. So beautiful question. A lot to learn from it. This was only there so that you'd see what are the other things we might have to work on. And these are the things which are conventional, mathematical. These are something which are not conventional, not mathematical. Specifically for some of you who are coming back from maybe preparation of IIT or maybe IIT, right? And maybe some of you from Olympiads, 100 in mathematics, in your 12th, maybe in your college, eco honors with maths, right? These are still some things, some area we need to explore. That is why I'm bringing out here. Hope you enjoyed these things. Yes, they're a little difficult, but that's not I am that if there is something difficult, I'll not bring it here. You have to see them, because you and I are working together for one goal, and that is a good score, or rather 100 percentile in your quant. So let's make it happen. Take care. All the best and see you in the next session.